So we all take it for granted now with modern technology that it's easy to go from place to place, no matter the distance we're traveling. But it's taken a long time for us to get to this point. Over the centuries, various devices have been created to make our navigation much easier. And in today's video, we're exploring the top 15 greatest navigational inventions. Let's start with number 15, the compass. Probably the most recognizable and widely used navigation aid of all is the compass, which is believed to have first originated in China during the Han Dynasty between 202 BC and 220 AD. The earliest ones were made using lodestones, which are naturally magnetized pieces of mineral magnetite, and while Chinese fortune tellers began using these lodestones in a divination practice, their potential for navigation was soon realized. By the Song Dynasty around 1,000 years later, the Chinese had developed a more advanced version using a magnetized needle floating in water, which pointed north to south. Quite how the compass made it to the will therefore align itself with the Earth's magnetic field, pointing towards the magnetic poles. And with very few exceptions, we'll be able to do this anywhere on the planet. Knowing the precise direction you're facing completely transformed our navigation, particularly for mariners who could now venture further into the open seas. And it brought in the age of discovery. Explorers like Christopher Columbus, Ferdinand Magellan, they relied heavily on compasses, and without them, they'd never been able to discover new lands and establish trade routes. Number 14, autopilot. Autopilot is now a vital technology that's used to help guide aircraft, ships, vehicles, and even spacecraft. And its introduction made navigation, particularly across long distances, far simpler, easier, and safer. It's a term that refers to various systems that are designed to perform complex navigational tasks with very little human intervention. And the first can be traced as far back as 1912. It was then that Lawrence Sperry demonstrated the first gyroscopic autopilot system and even execute emergency maneuvers if necessary. Commercial airliners now rely heavily on autopilot systems to ensure a smooth, efficient, and safe flight. Pilots use this technology to manage routine operations while maintaining manual control for critical phases such as takeoff and landing. Where autopilot truly is interesting, though, is how it's about to completely change the idea of personalized transport with its incorporation into self-driving cars. With most automotive manufacturers now developing their own versions, every vehicle could soon be running by itself. Number 13, the sextant. The sextant is one of the most famous devices in navigation history, and after being invented in the 18th century, it gave sailors an incredibly precise way of determining their longitude and latitude. Its name comes from the arc shape, which precisely is 1/6 of a circle, or 60 degrees. The instrument's used to measure the angle between two visible objects, such as the horizon and a celestial series of mirrors and a graduated arc. This allowed navigators to measure angles with extremely high precision and allowed them to calculate their exact position at sea. By measuring the angle between the horizon and the sun at noon, they could determine their latitude, and for longitude, they would compare the local time of a celestial event with the time they knew it was happening somewhere else. The sextant was another device that was crucial during the age of exploration, with explorers like Captain James Cook relying on it heavily. Cook's expeditions, which mapped much of the Pacific Ocean, used sextants to create detailed charts that were still relied upon until surprisingly recently. Even today, with far more advanced alternatives, the sextant does remain a trusted tool for those at sea. It is a reliable backup in case of electronic failures, and it continues to be part of nautical training. Number 12, stick charts. Stick charts, they were a form of navigational tool that were used by the Marshallese people of the Marshall Islands in the Pacific Ocean, and unlike anything anyone else had sonic devices representing the wave patterns, currents, and other maritime phenomena that could be found in their waters. There were several types of these stick charts, each serving a specific purpose. The matang was used for training and teaching the principles of wave navigation. It was made up of a simple geometric design that showed the interaction of ocean swells. The rebelib covered large sections of the Marshall Islands and depicted major ocean swell patterns and island positions. The medo, or more detailed chart, showed the wave patterns around individual islands and atolls, providing critical information for approaching the land. Now, the construction of these charts was both an art and a science. The sticks were made from coconut fronds or other flexible materials. They represented the prevailing ocean swell patterns, which are influenced by the wind and currents. Shells or small pieces of coral were tied to the sticks to show the locations of the islands or atolls. The intersections of the sticks represented the understanding of how waves interact with the islands, creating a pattern that were memorized for centuries, the danger of running aground. Especially in stormy weather, it was virtually impossible to know how deep the water you are sailing in is, and with the ability for the seafloor to change over time, you couldn't fully rely on charts. The only way mariners could take regular readings was with lead lines, which involved dropping a weighted line marked with the depth measurement and noting the depth where the weight touched the seabed. This process was time-consuming and slowed progress, especially in deep waters or when frequent depth readings were necessary. Today, there are echo sounders, which use sound waves to measure water depth and detect underwater obstacles, and have significantly enhanced our safety and efficiency in maritime travel. The principle of how an echo sounder works is pretty straightforward. A transducer emits a sound pulse that travels through the water, reflects off the seabed or an object, and returns to the transducer. By measuring the time it takes for the echo to return and knowing the speed of sound in water, which is around 4,900 feet or about 1,500 meters per second, the device calculates them to adjust their course or to avoid hazards. Number 10. The Traverse Board. The Traverse Board is a simple yet clever device that used to be used by sailors to record the ship's speed and direction during their watch, and helped with much more accurate navigation over long voyages. It is essentially a wooden board with a series of holes and pegs. The upper part of the board has a circular pattern representing the compass points, divided into 32 sections that correspond to the directions of the compass. Below this are 2 rows of holes that are used to record the ship's speed. The top row is usually divided into half-hour increments, while the bottom row records the speed in knots. Using a traverse board was pretty straightforward, and every half hour the ship's helmsman or navigator would note the ship's heading and speed. A peg would be placed in the hole on the compass to show the direction, and another peg would be placed in the hole corresponding to the ship's speed. Over the course of the watch, these pegs created a record of the ship's course and speed, which could then be used to plot the vessel's position on a chart. It also helped sailors develop a better understanding of navigation and seamanship simply by using it, as it required them to learn how to estimate speed, understand wind patterns, and maintain accurate courses. This was crucial at a time when formal training was limited and much of a sailor's knowledge came from hands-on experience. Number 9. Chronometer. The chronometer. It was a groundbreaking invention for sailors. It gave them a reliable way to calculate their longitude when at sea. This had become a significant issue for early seafarers, as while latitude could easily be calculated using the position of the sun or the stars, longitude required knowing the precise time at a known location, usually Greenwich Mean Time, while also knowing the local time at the ship's current position. Before the chronometer, methods such as dead reckoning and celestial navigation were imprecise and often led to significant navigational error. The first marine chronometers were designed by John Harrison, an uncompensated balance wheel and an advanced escapement mechanism to ensure the device kept accurate time. This meant that sailors could work out their longitude within a few nautical miles, which was a major improvement over previous methods that made the difference between a voyage success or failure. It soon became the essential tool for explorers and naval officers, and it was Captain James Cook's successful use of one on his second voyage to map the South Pacific, which was done with unprecedented accuracy, that led to it being used across the British Royal Navy. The earliest ones weren't perfect though, and the development and refinement of marine chronometers continue through the 19th century, with manufacturers such as Thomas Earnshaw and John Arnold contributing further improvements. By the mid-19th, chronometers had become even more reliable and were standard equipment on every vessel used for long-distance voyages. Number 8. Radar. Radar, which stands for radio detection and ranging, is more commonly thought of as being a way to detect aircraft radio waves to return and the strength of the return signal. Radar systems can determine the distance, speed, and sometimes the shape of objects. In maritime navigation, radar is indispensable. It provides sailors with a real-time, all-weather means of detecting other vessels, land masses, and hazards. It is crucial in poor visibility conditions such as fog, heavy rain, or during the nighttime, and allows ships to navigate safely through congested water. These systems can calculate the closest point of approach and help navigators make informed decisions. In aviation, radar is just as important. It enables air traffic controllers to monitor and manage the movement of aircraft in a controlled airspace, ensuring safety. Primary radar detects aircraft by reflecting radio waves off their surfaces, while secondary radar surveillance interacts with transponders on planes to provide additional information, such as altitude and identification codes. Its role in weather detection is also pretty critical for safety on sea and in the air. Weather radar systems help identify and avoid hazards. Navigation lights is governed by international regulations to prevent collisions and ensure the safe flow of traffic in busy waterways and airspace. On the seas, navigational lights are essential for communicating a vessel's presence and intentions to other mariners. These include a red light on the port side or left side, a green light on the starboard or right side, a white stern light at the back, and a white masthead light at the front. These then help others work out a direction a vessel is heading in and its relative position. For example, if you see a red light, you'll know the other ship is approaching from the starboard side and should give way. Similarly, seeing a green light tells you that the approaching vessel is on the port side and it should hold its course. In aviation, navigation lights work in a similar way, helping pilots maintain situational awareness and avoid mid-air collisions. Aircraft are equipped with a red light on the left wingtip, a green light on the right wingtip, and a white light on the tail. These lights make it easier to determine an aircraft's orientation and direction of trackability. Number 6. The astrolabe. The astrolabe is an ancient astronomical instrument that originated from the classical Greek world, and it was further refined by Islamic scholars to become what's generally seen as one of the most sophisticated pre-modern scientific instruments. The name comes from the Greek words astron, which means star, and lambanon, which means to take. This device essentially is a portable model of the universe, and it's made up of several key components. There's the mater, or base plate, the tympan, or the climate plates, the rita, or the star map, and the aldade, or sighting rule. The mater is the main part of the astrolabe, into which the tympans fit, each engraved with a projection of the sky for a particular latitude. The rita is a rotating framework that represents the ecliptic and several prominent stars, and by rotating it, users can simulate the motion of the stars and the sun. After being improved by Islamic scholars during the medieval time, reached Europe, and was really important in the Islamic world for keeping track of prayer times. Number 5. The AIS. The Automatic Identification System, which is known as AIS for short, was developed mainly to prevent collisions and improve maritime traffic management. It was first introduced in the late 1990s and became mandatory for certain classes of vessels under the International Maritime Organization's Safety of Life at Sea regulations by 2004. The system uses VHF radio frequencies to transmit and receive information between ships and shore-based stations. Each vessel equipped with an AIS sends out regular broadcasts containing its unique identification, position, speed, course, and other relevant data. These broadcasts can then be received by other AIS-equipped vessels and shore stations within range, usually up to 40 nautical miles, although satellite AIS can extend this coverage significantly. The main intent behind AIS is to avoid collisions by optimizing traffic flow, reducing congestion, and ensuring a safe passage. In recent years, the satellite AIS has expanded the reach of this data collection to uncover the entire world. This involves satellites equipped with AIS receivers that capture data from vessels beyond the range of terrestrial VHF signals, and its improved awareness, enabling the tracking of ships even in remote and open ocean areas. Something that's really valuable for monitoring the movements of large fleets, tracking illegal fishing activities, and ensuring security of maritime trade routes. Number 4. Chip log. The chip log, also known as the common log or ship log, is a simple instrument that was historically used by sailors to measure the speed of their vessel. This device played a critical role in navigation before the introduction of modern technology, enabling mariners to estimate their ship's speed and therefore the distance they've traveled. The chip log is made up of a wooden board, or the chip, that's attached to a line that has knots at regular intervals. Along with a method has it provided a relatively accurate and consistent method for measuring a ship's speed. Using the chip log, though, did require skill and coordination to get a reliable reading, with the sailor needing to throw the chip overboard at the correct moment, ensure the line unraveled without tangling, and being able to accurately count the knots while watching the timer. This method also did have some major limitations, with factors such as the state of the sea, currents, and wind potentially affecting the accuracy of the speed measurement. Still, it was much better than any alternative at the time, and it would be hundreds of years before something more reliable was introduced. Number 3. LORAN. LORAN, which stands for Long Range Navigation, is a terrestrial radio navigation system that was developed during the Second World War. It would go on to play an important role in maritime and aerial navigation, giving reliable means of calculating a position over long distances, especially in regions where other navigational aids were unavailable. The development of this system began in the US in 1940 because of the nation in a chain transmits synchronized pulses of low-frequency radio waves, and a receiver on a ship or aircraft picks up those signals and calculates the difference in arrival times, known as time differences, from pairs of stations. By plotting these TDs on a specially designed chart, navigators can determine their precise location. The initial version of it had a range of about 600 to 1,200 nautical miles, depending on the transmitter power and the atmospheric conditions. It became the preferred navigational aid for commercial shipping, aviation, and even personal navigation for recreational boaters and pilots for a time. Despite significant improvements LORAN offered, it's rarely used at all anymore. It came at a time when satellites were beginning to be launched into orbit, and with just in a few decades, far more precise and reliable systems would become available. Number 2. Cross-staff, backstaff. The cross-staff and backstaff are two historical devices that were used in navigation to measure the angle between a celestial body, such as the sun or a star, on the rod, giving the altitude of the celestial body. This instrument was relatively simple to construct and use, making it accessible to sailors of various skill levels, but it had one major problem. The user had to look directly at the sun to take a measurement, which could lead to eye damage and inaccurate readings. To overcome this problem, the backstaff was developed in the early 17th century by the English navigator John Davis. The backstaff allowed navigators to measure the altitude of the sun without looking directly at it, reducing risks and improving accuracy. The navigator would stand with their back to the sun and then use the instrument shadow to measure the sun's altitude. The backstaff was a significant improvement over the crossstaff, providing more accurate and safer measurements. It soon became a standard navigational instrument for most sailors, particularly those on ships exploring new trade routes and land. Number 1. GPS. Could it be anything else? The Global Positioning System, GPS, is a satellite-based navigation which showed that satellite signals could be used to determine a precise location on Earth. Building on this idea, the United States Department of Defense initiated the development of the GPS system in the 1970s. The first satellite was launched in 1978, and the system became fully operational in 1995. GPS operates through a network of at least 24 satellites orbiting the Earth at an altitude of around 12,500 miles, or about 20,200 kilometers. These satellites are continuously transmitting signals that contain their current time and position. The GPS receiver on the ground picks up signals from multiple satellites and uses the time it takes for each signal to reach each receiver to calculate its distance from each satellite. By triangulating these distances, the receiver can determine its precise location, often within a few feet. Unlike other methods like LORAN, the fact that the signals are being transmitted from space makes all the difference. Weather systems don't interfere with the signal as much, and unlike land, to enhance accuracy and reliability. The success of GPS has also led to the development of other global navigational satellite systems, such as Russia's GLONASS, the EU's Galileo, and China's Beidou. Each of these systems operates independently, but it's designed to be compatible with GPS, providing users with even greater accuracy and coverage. Thanks for staying with me, everyone. I'll see you next time.